You're out of this world. What galaxy are you from? I am also from the Milky Way galaxy. Do you like Star Wars? I like Star Wars. They travel all over the place in space. So, our learning target today is I can describe how the solar system appears to have formed from a disk of gas and dust drawn together by gravity. So there's this thing called the Big Bang Theory. Say it with me. Big Bang Theory. Not the show. But if you watch the beginning of the show, after today's lesson, if you watch the beginning of the show and you know about Sheldon and his clan of nuclear physicists, you will understand. The Big Bang Theory is the idea that the universe began as a huge explosion 15 billion years ago. So, where did it all start? We think with the Big Bang. You're going to watch a video that will help explain it better. Here's our second important term today. It is galaxy. Say it with me. Galaxy. It's a system of billions of stars, gases, and dust. Some of the stars that you go out and look at night might actually be so far away that they appear as one light source, and really, they're not. Maybe they're 6 or 7, or maybe they're just a galaxy of stars. There are millions of them out there. But galaxies are a system of billions of stars and gases and dust. So if you ask me, is there life out there? The possibilities are pretty good. Billions of stars? Maybe there's a planet that's relatively close to one that can be just the right temperature for life. Today, you're going to see 3 main types of galaxies, and I would like you to draw them here. It's kind of fun to draw them. And I want you to fill in this right here. The Milky Way galaxy is a certain type of galaxy, and I'd like you to fill that in here. And Earth is located on an arm of the Milky Way galaxy. As you look into these things today in your lesson, you will find some interesting places to do some extra credit if you want. Just on a side note, in case you were wondering, there are 200 billion stars in the Milky Way galaxy, and the Sun is one of them. By the way, the Sun is not the biggest one either. There are some big stars out there, and the Sun is not a big star. It's just a medium-sized star. Today, I would also like you to think about gravity. Have you ever seen videos where people go out in space and the astronauts kind of floating around? Is there gravity in space? Well, there is gravity in space. Every single atom has gravity. It just matters how big you are. So astronauts literally have gravity in space, but because they're so small, it's negligible, like it's very little. So they float around like anti-gravity. When they get closer to the Earth, though, the force of gravity is so strong because Earth is so big, it pulls objects to the Earth. That's why your feet stay on the ground and you don't float around Earth, because of gravity, right? So our next learning target is, I understand gravity affects the motions within galaxies and the solar system. Important term today, gravity. Say it with me. Gravity. It's the force of attraction between all objects that have mass. Today is tricky. I'm going to ask you to watch the Magic School Bus, but it comes in a little tiny video, so make sure you're listening, and then when the video is actually done, listen to the phone calls afterwards, so any of the misconceptions that are in the video, you can understand. I want you to watch and listen for how something that's big has more gravity than something that's small, okay? So, our question that I want you to watch for is, why does the moon orbit Earth instead of the sun? I mean, the sun's there, and the Earth goes around the sun, but how come the moon doesn't orbit the sun? Your answer here. Everything has gravity. Explain how mass affects the strength of gravity. So, the bigger something is, the more mass it has, maybe the more gravity it has. The smaller something is, remember we talked about the astronaut floating in space. It's not a planet or a star. And so the gravity is very small. Also, we stay around Earth, just like the moon stays around Earth, because of the force of gravity. It has to do with our distance, okay? The last question I want you to think about today is, what would happen to your weight if you went to Pluto? Remember, Pluto is a very, very, very small, smaller than our moon. So very much smaller than the Earth. What would happen to our weight if we went to Saturn? Saturn is very, very big, much bigger than Earth. So Pluto and Saturn both might have different gravitational strengths. And you get to put your answer here. Today, you'll watch a couple of videos, you'll read some basic information off of a couple of websites, and you will submit notebook page 54 with the link. All right, may the force be with you. Gravity, I mean.